Thank you so much for joining this lesson. We shall be discussing differentiation together with its applications in curve sketching, determining turning points together with their nature. Remember to subscribe and also to share this platform with your friends. The equation of a curve is given as y equals to 3x power 2 minus x power 3. Part A, determine the coordinates of the turning points of the curve. Turning points of a curve are also called the stationary points of the curve. And for us to determine the stationary points of a curve, one thing that you're supposed to understand is that at the turning points, gradient of any curve is usually 0. Therefore, we first get the gradient function, which is the derivative of the curve's equation. Therefore, we're going to derive y with respect to x so that we may get the gradient function. To differentiate the first term here, we drop the power, which is a power 2, multiplying 3 to make it 6. Then x is now power 1. So the power reduces by 1. Minus the power here is dropped. The coefficient of x power 3 is -1. So -3. Okay, 3 times -1 is just -3. And x is now squared. This is the gradient function of the curve. Now, at the turning points, gradient is usually 0. Therefore, we say 6x minus x power 2 equals to 0. Solving this will help us to get the values of x at the stationary points. When the gradient equals to 0, what is the value of x? So we can factor out x so that we remain with, this is a 3x, sorry. So what to be factored out here is a 3x, which is common. We remain with 2 minus x. This is equal to 0, meaning that either 3x equals to 0 or 2 minus x equals to 0. The value of x is 0, and the value of x can also be positive 2. So we have the two values of x at the stationary points. Now, with the values of x at the stationary points, we can substitute in the original equation for us to know the values of y at the respective values of x. When the value of x is 0, what shall be y? When x is 0, then y shall be x squared minus x power 3. X power 3 is substituted with 0, and this is just 0. So one of the coordinates is 0, 0. That's one coordinate. Another coordinate is when the value of x is 2, then y shall be x squared, according to the original equation, 3x squared. So 3x squared. Let's substitute in the right way. But remember, even if you substitute 3 at this point, it shall still be 0. So 3x squared minus x power 3. That will, the value of y shall be, 3 into 2 squared minus 2 power 3, giving us positive 4, meaning that this other coordinate is 2, 4. So we are having two coordinates for stationary points, rather for turning points. So at the turning points, we have coordinates 0, 0, and 2, 4. Those are the two coordinates for the turning points. The same question, part B. Determine the nature of the stationary points. For us to determine the nature of the stationary points, we have to establish whether they are maximum points, minimum points, or points of inflation. So we'll be getting into that. In the meantime, allow me bring to your attention our program for the holidays. We are calling it the One Term Ahead program. Therefore, if you are a continuing student, JS or senior school, you are much invited to our program from the 20th of November to 12th December 2025 via Google Meet. Google Meet offers very interactive programs. We shall be covering the term 1 work of 2026. So when you'll be opening for your next level, you shall be one term ahead of the others. Please meet with us. All the levels, we shall be offering all the compulsory subjects. Remember, our consultation line is already attached here, 0704 15 366. We can meet for a serious discussion and interaction with very powerful teachers. Those who are in Form 4 2025, we have a program for every Sunday, a mentorship program in mathematics. Kindly feel much invited to our classes via Google Meet. Again, very interactive. You can reach out for more details through the number which is already attached. Otherwise, thank you so much. Let's now continue with differentiation. Determine the nature of the stationary points. Now, for us to determine the nature of the stationary points, we're supposed to understand the behavior of the curve or the behavior of the gradient just before and just after the gradient, the turning points, just before and after the turning points. On that note, allow me come up with some two tables here, whereby we can have the value of x at the stationary points, then the value of gradient, and finally, the nature or the behavior of the curve. So at the middle here, we can insert x as 0 at the stationary point. Then we check just after the turning point at a point like 1, and before the turning point at a point like -1. How is gradient behaving at these particular points? At x equals to 0, gradient is also 0 because that's at a turning point. What about at x equals to -1? How shall be the gradient? So this is the gradient function. At x equals to -1, what shall be the value of gradient? 6 into -1 minus 3 into -1 squared. This gives us exactly -9. This gives a gradient of -9. Then at 1, whereby now it's a point beyond the turning point. 6 into 1 minus 3 into 1 squared. This gives us exactly 3. The value here is 3. So according to this, we have a gradient of 0. Then just before 0, there is negative, and after 0, there is a positive. So the gradient is moving from negative gradient slopes this way, through 0, which is flat, then now becoming positive. You see the nature of these. So we can say coordinate 0, 0 is a maximum point. That's a maximum point. Gradient is turning from negative through 0 to positive. Then we go to the next turning point. Turning points are 2, and we are determining the nature for both of them. Again, we come up with just a brief table to help us analyze the behavior. The other turning point is at x equals to 2. So at x equals to 2, at x equals to 3, a point just beyond the gradient. Then at x equals to 1, a point which is just before the turning point. These are values of x. Then how is the gradient itself? So when x equals to 2, gradient is 0 because that's a turning point. When x is 1, gradient is 3. We substituted 1 in the previous working. What about when x is 3? What will be the value of gradient? X equals to 3. We get back to the gradient function, say 6 into 3 minus 3 into 3 squared. This gives us -9. This gives us exactly -9, like that. Can we analyze this behavior of the curve? Gradient is changing from 3, which is a positive gradient, through 0, then to negative. So we can now conclude that 2, 4 is a minimum, actually this is now a maximum point. Maximum point, the highest point, because it's turning this way. That's a maximum point. Yeah, it's a maximum point. Looking at the other one, this is how it's turning. So the first one here was a minimum point. That's a minimum point. So we have a minimum point and a maximum point as the natures of the stationary points that were determined in part B. Look at part C of the question. Determine the intercepts. To determine intercepts, these are points where the lines or the curve cuts the intercepts. So we will say at y-intercept, the value of x must be 0 because that's along the y-intercept. So if x is 0, then we substitute in the original equation here. So y equals to 3, 0 squared minus 0 power 3, giving us 0. At x-intercept, the value of y must be 0. Therefore, we say 0 equals to 3x squared minus x power 3. So the values of x from this have already been determined. Not yet. The values of x can be determined now, whereby we shall talk of, we factor out x squared to remain with 3 minus x all equal to 0. So x squared equals to 0, meaning that x is 0, and 3 minus x equals to 0, meaning that x equals to 3. So the x-intercepts are 3 and 0. 3 and 0. And finally, we are told to sketch a curve. So to sketch a curve, we consider the intercepts and we also consider the turning points together with their natures. Yeah, turning points together with their nature. This is point 0. Then we can talk of one of the turning points is a 0, 0. Another one is 2, 4. So 2, 4, that's a turning point. X-intercepts, one is at 0, 0, and another one is at 3. So a turning point. Then y-intercepts, it's only one at the intercept. So this is a turning point also, 0, 0. So this is a minimum point, meaning that at that point, the curve turns this way. Then the other one, which is a maximum, the curve turns this way. Okay, let me check. That's not another turning point. Just a point where the curve cuts the x-axis. So that point is just passing. So we have the two turning points and we have the intercepts where the curve is passing. So that's how we sketch the curve. You consider the intercepts and also we consider the nature of the turning points so that you may turn appropriately. Then I ask you, how have you been loading airtime to your lines? You can simply use our model here, which is very quick and efficient. You just go to your M-Pesa, Lipa na M-Pesa option. Paybill number is already attached on the board, 737356. Then the account number is the phone number that you're purchasing the airtime for. Be it Safaricom, Airtel, Telcom, any network line, you will receive your airtime. Then you proceed to enter the amount, you complete the transaction, and your airtime is reflected instantly. So thank you so much for joining us. See you another time.